Please welcome David Wallace-Wells, opinion writer and columnist for the New York Times Magazine, and Stefan Rahmstorf, professor of physics of the oceans at Potsdam University, and Michael Oppenheimer, professor of geosciences and international affairs at Princeton University.
Thank you. Thanks, everybody, for coming to this talk. Thank you guys for being on stage here. I'm especially excited to be talking with two of the world's leading climate scientists, because personally, I often worry that when we get excited about and talk about the energy transition, the geopolitics of green energy, we sort of forget why we're rushing to do all that in the first place. And that reason is that climate science keeps telling us that things are really quite scary and will be even scarier if we don't change course pretty rapidly. So we're here today to talk about some of those risks, and in particular, the risks that we sometimes call tipping points. So Stefan, I wanted to start with you. Just very briefly for the audience, what is a climate tipping point?
Well, there is physical tipping points and biological tipping points. The word tipping point actually comes from ecosystem science, or at least it was used there quite a bit. Ecosystems can tip over from one state to another, like a forest burning down because of drought problems, etc. But in physics, there's a very clear definition, and that is tipping point is when a physical state is not changing because it is pushed further, but at some point self-amplifying feedbacks take over, and then it changes further without further pushing by itself, unstoppable. It's like with this chair, it doesn't work well. If I push back here and wobble on my chair, I have to push. But from a certain angle on, I don't have to push anymore. It will just fall over. And that point where this happens is a tipping point.
And one of the most talked about, worried over ones concerns the AMOC, which is a circulation system in the northern Atlantic. And wanted to maybe ask you to tell the audience just consequences if we do reach that tipping point with the AMOC. What happens if that circulation system shuts down? How different would the world look? How big a deal would that be?
Well, it would be a huge deal. You have to understand that the AMOC is a huge flow of water that warm surface water goes northward along the entire Atlantic from South Africa right into the Nordic seas. It sinks down to between 2,000 and 3,000 meters depth after giving off its heat to the atmosphere, and then returns as a cold current that works like a central heating system for the northern Atlantic region. So if you shut that down...
Which means it sort of controls the temperature distribution of the half of the
Exactly.
planet, right?
It is a key reason why Europe, especially northwestern Europe, has a very mild climate for its latitude. And if you shut that down, that advantage will go. It will get a lot colder in especially Great Britain, Scandinavia, of course, Iceland. But there are other consequences of worldwide impact. One of them is a shifting of the tropical rainfall belts. They are where the Earth is warmest, which is now north of the equator because of the northern hemisphere being warmer than the southern hemisphere by 1 to 2 degrees Celsius. Because of that cross-equatorial heat transport by the AMOC, if you shut that down, tropical rainfall belts move south. We know that because it has happened in Earth history. The AMOC has shut down repeatedly, so we know it's unstable. We know then the tropical rainfall belts shift. That means for tropical countries, the rainfall is not where people are used to it, where the tropical rainforests are. There it will be missed, and in other regions which are not used to these extremely high precipitation amounts, there will be flooding. So that's another effect. There is also the effect on sea level. Sea level will rise by about an additional 50 centimeters or so around the North Atlantic, including the American Atlantic coast, if you shut down the AMOC. So that's additional rise to the global mean rise. There's the effect of less CO2 uptake by the ocean because the water sinking down to a couple of thousand meters depth takes CO2 down. If that stops, that will not happen anymore. So atmospheric CO2 rises faster. And finally, disruption of marine biology in the whole Northern Atlantic region, inclusive the fisheries.
So this is really a remapping of the world's weather and biological and climate systems at a very basic level. And this is a risk, this tipping risk of AMOC that just a few years ago climate scientists thought was vanishingly unlikely this century. But over the last few years, a series of papers have come out suggesting a much higher risk. And I think you've said publicly that you think that there's now a greater than 1 in 2 chance that it happens this century. So maybe explain a little bit why we've gone from thinking that this was quite scary but quite unlikely to just as scary as we always knew, but considerably more likely than we thought just a few years ago.
Yeah, I mean, it was never considered vanishingly unlikely. The IPCC report some years back said it is very unlikely, but in IPCC uncertainty language, that means less than 10%. So if I tell you your plane that you're flying to somewhere has a less than 10% chance of crashing, I don't think you would find that reassuring. So it has never been that unlikely, but yeah, unlikely. Very unlikely, whatever, but still a big concern. But now, first of all, we see already that the Northern Atlantic is the only region of the world that has cooled in the last 100 years and keeps cooling down. And that is exactly the region where the AMOC delivers its heat and where the climate models predict that will cool when the AMOC slows down. So we see this happening. Also, that region, which is to the west of the British Isles, south of Iceland, has now the lowest salinity, so ocean water salt content, in 120 years of measurements, which again is an expected effect of an AMOC slowdown because it doesn't only deliver heat but also salt from the subtropics to that region. And so we see things are happening there. Then there's a whole new type of studies, the so-called early warning signal studies. There are 4 of them that I know of with different data sets. They try to use not models, but observational data to see how close might we be to the tipping point, when might we cross it. And they kind of indicate that it's quite likely already this century, probably even before 2050, that we could cross that tipping point. These studies are quite uncertain, so there's big uncertainty range there. One study said like between 2025 and 95, so it's a big span, but it's all within
2025 is next year also.
Exactly. Yeah. I mean, it could even, that's not ruled out that we cross this tipping point in the next few years. That is a reason of concern. And then also it has been only recently become known that these typical IPCC models that end their simulations in the year 2100, when you run them longer, nine of these models have been run longer now, for high emission scenario, the AMOC collapses in all of those in the next century. So, but it's already on the way before 2100. So that is all evidence that it is now, to my mind, a definitely much larger risk than I thought 5 years ago or 10 years ago.
So, Michael, to my sort of lay brain, when I hear the story of the AMOC and what we're facing if it possibly shuts down, temperatures, I don't know exactly the figures are, 10 to 20 degrees colder in Europe, scrambling of the world's weather patterns. This seems to me to fit a pretty intuitive mental model of what a tipping point should be. But I know you have some misgivings about thinking about some of these and talking about some of these climate shifts in the language of tipping points. So tell us why. Why is this an incomplete or imperfect way of talking about these risks?
Well, I think Stefan gave us a good analysis of the science on this one tipping point. Some of the tipping points are misclassified, frankly. And even with the AMOC, if the physics is like a tipping point, actually from the point of view of an average person or a policymaker, it's not even a point. There was a paper 2 years ago which analyzed the full set of models that had looked at it, and their analysis was, it could be triggered any place between 1.5 and 8 degrees Celsius above pre-industrial levels. We're now around 1.2 degrees. And it could take about anywhere between 50 and 300 years to play out. I think about these things in terms of, not just as a scientist, but what does the average person think of that? What do policymakers think? It's very hard for a policymaker to hang their hat on something that has that range of uncertainty. And for the average person, if you tell them you're about to go over a cliff and there may be nothing we can do about it, it's likely that with a lot of people, it disempowers them and they give up. There have been studies of this. So the frame is both questionable from the point of view of the characteristics, which are abruptness, irreversibility, self-pumping itself up, self-acceleration or feedback, nonlinear feedback, and surprise. A lot of the 15 or so tipping point systems don't have one or more, and some of them don't have any of those characteristics. So that's a problem with the framing. But more important, there's a lot of bad stuff starting to happen due to climate change already. How much are you going to be concerned, or should you be concerned today about something that may or may not happen 50, 100, 200 years from now? I think it's appropriate to regard it as part of a bundle of risks, but it shouldn't be the dominant one in your mind. What should be dominant, and is dominant in my mind now, as someone who's worked on the ice sheets for a long time, another tipping point, is that we have these impacts. We are not adapting to them successfully. Our government hasn't set up either the institutions, that is the US government, or the finances, or the research necessary to really understand what we should be doing now to protect ourselves. And as a result, we're marching into the next 30 years, a period over which it almost doesn't matter how much we reduce emissions. We're going to get the same increase in short-term impacts: record heat, too much rain and rainstorms, probable intensification of hurricanes, et cetera. You've heard the list. And, we don't have a plan. And that's not just the US government, it's many other governments. It's not just at the national level, it's at the state level. We don't have the money in it, we don't have the plans. I worry more about that than I worry about these large-scale tipping points. And if we decided to grapple with the short-term risk, we would probably do more or less the same thing that we're going to do to deal with the AMOC, for instance. What we're going to do, we've got to cut emissions as quickly as is feasible. We're not doing that. We could do better. We're doing better than we used to. And we've got to get, equally important, a program together to get to deal with these impacts that are going to happen no matter what we do on the emissions side over the next few years. The emissions cut will reduce the growth of deaths from heat waves. 60,000 people died in Europe in 2022, for instance, from excess heat, a lot of which was due to the buildup of the greenhouse gases. And there are a lot of other effects like that that are just going to grow. And yes, we can cut into them, not much for the next 30 years, but for later in this century, when the children of people in this room will still be alive, for instance. And, okay, at the same time, if we make those aggressive emissions cuts, and if we protect ourselves in the meantime by learning how to adapt, we will also be cutting the risk of the big things that are talked about, like the AMOC. And if we don't learn how to adapt, it may become irrelevant what the AMOC does or does not do, because we may be toast just from these more quotidian things that we're unfortunately sort of seeing more and more. And by the time the AMOC collapse comes around, if it's going to come around, it may be almost irrelevant.
So you talked a lot about how our understanding of these systems should inform our policy, our planning, our adaptation investments. There's a sort of a how are governments responding line of thinking. But I'm also just curious how you think about it as a human alive on the planet. I mean, when you started your answer, you talked about two big uncertainties around the AMOC in particular. We don't know exactly at what temperature level we might expect a shutdown, and we don't know exactly how fast it would happen, right? Both of those are big scientific uncertainties. But if we're limiting ourselves in thinking about future risks to those things that we know are going to happen or know are going to happen soon, is that not a little bit like, looking for the keys under the lamppost as opposed to trying to find out? Yeah.
You could flip the argument around and say, okay, Oppenheimer, we accept your argument. We'll do as much as we can on emissions, but we're not going to quite make it in terms of avoiding the risk of one of these big global scale changes. And we're going to learn how to adapt as best we can. But then something like the AMOC collapse happens anyway, and we're just not up to it. And then, you know, the human race isn't going to go extinct, but life would become very hard for a lot of people. As usual, it's poorer people in poorer countries that take it in the neck mostly from things like this, but it'll affect us too in a significant way. So, yeah, you could make that argument. From my mind, knowing how inept many governments have been on this problem and still are, I just decided that the most important immediate focus, for me personally, is to worry about the people who are already suffering and how to cut that and how to reduce that risk, because the same actions, both on emissions and adaptation, will benefit us in the long term.
And Stefan, how do you think about this? I mean, on the one hand, you have a set of things that we know are happening, know are causing problems. We can do some things to respond on the mitigation side. Probably more things to do can respond on the adaptation side. But then there's a whole category of risks, the tipping point risks, maybe most notably, where we don't really know exactly the probabilities. But we know that if they happened, they would be really quite bad. How do you balance those two sets of risks in your mind? How do you think about how we as a society should be approaching them and balancing our own focus between the things that we know are coming and have some clear picture of, and the things that we're just scared might be happening, and if they happened, would be really quite catastrophic? How do you balance those two?
Well, it's not an either-or issue, obviously, and it's a bit like if I have high blood pressure and I go to the doctor and the doctor says, well, it's because you're a heavy smoker, so you should stop smoking, otherwise your blood pressure will get even higher. Then the doctor will hopefully probably say, and also there's a risk you get a stroke, which would then be disastrous. And so, of course, the doctor has to tell me about that risk as well. And that's what we scientists studying these tipping point risks are doing. And I don't know anybody who would have claimed that that should be our dominant concern, but it is definitely an additional concern, which probably also means that, you know, if you say, okay, we stand whatever 60,000 heat deaths in Europe, etc., and maybe it doesn't matter if there's 1 or 2 additional tenths of a degree warming, but if you know there's a tipping point out there that you might cross in these 0.2 of a degree extra warming, with disastrous consequences, that might just put some additional pressure on to actually prioritizing sticking to the Paris Agreement. And I agree with you, it doesn't ask for anything new. It simply asks to do what has been unanimously decided by the world's countries already, namely trying to limit warming to 1.5 degrees. Of course, this is hardly possible anymore, 1.5, but we can kind of stop at 1.6 or 1.7, and we should really try to do that.
Yeah, I was going to ask a sort of a version of that last point to you, Michael. I mean, how do you assess how we're doing in this big project of limited? I mean, you've been working on this for quite a long time in between science and policy. You know, if we set these goalposts, these speed limits in 2015 in Paris, like, what does it mean to be racing past them now? And how do you think about the speed at which we're traveling?
You know, I mean, my feeling, and others share this, is that already in Paris, people knew that we didn't have much of a chance. I mean, there was a well-known paper that was published just before Paris and analyzing what the chances of meeting 1.5 degrees were, and it was quite small, and it hasn't gotten any better in the meantime. We're gonna, if we meet it, it'll be, first of all, see it in the rearview mirror, and then meet it on the way back down after we really get things under control. But, you know, I tend to be an optimist. And I'm looking for the good stuff, and there is a lot of good stuff happening out there. There are changes in, for instance, U.S. policy, the Inflation Reduction Act, the Infrastructure Act, the regulations that the Supreme Court may or may not let stand are going to and have already probably started to make a difference in the U.S. energy economy. We're not the only ones. The Chinese are moving like crazy to take over large parts of the renewable energy business. And not just the energy, but the users of the energy, like cars, high-speed trains, et cetera. So, that, you know, that isn't great for American labor, maybe, but it's good for the world in a way. So I think that We ought to look to these favorable, and they're more than just straws in the wind. They're real things that are happening. Keep encouraging them, and at the same time realize that we're going to pass some of these thresholds, certainly 1.5 degrees, maybe 2 degrees, but I think we have a fairly good chance of stopping the warming a little north of 2 degrees. And if we can do that, we won't have eliminated the chance of a collapse of the AMOC. We won't have eliminated the chance of an eventual large loss of ice from the Greenland and Antarctic ice sheets, but we will have reduced the risk significantly. We don't live in a perfect world. You can't let the perfect be the, whatever the expression is.
Yeah.
So we're gonna muddle in. We're gonna muddle along. Humans have done this forever. They create problems, and by and large, although not entirely, we clean them up afterwards. Now, the world looks particularly shabby right now, but we're still going to be here, and we ought to make the best of the fact that we're not going to disappear.
Well, on the cleaning up after point, I mean, you talked mostly in telling just a modestly good story, but about the decarbonization side of the equation. How do you see the adaptation side of things? I mean, we're creating problems for ourselves in the near-term future. We're certainly creating problems for future generations. Some of these suggest quite large demands on us to, we will have to do a lot to protect ourselves in the face of these risks. How do you see that side of the equation? Are we moving there anywhere near the speed we're moving on decarbonization?
No, then that's why I try to emphasize adaptation right now. I don't think by any means that emissions reduction and decarbonization is taking care of itself. It needs to be pushed and tended in every country, including and especially our own. But we've put far more money and far more attention on that side, and really not enough on figuring out how to give people the tools to protect themselves. Some adaptation is individual, some of it is collective, and the government has most of the resources which allow individuals to do the things they need to do, like putting hurricane clips on the porch of your home, for instance. So that's where there's been a sort of a disregard for the problem. Oh, it's funny. It's not funny, ha-ha, but it's peculiar. It's as if in the face of this stuff starting to happen, they're sitting there scratching their heads. The U.S. Army Corps of Engineers, the big builder of infrastructure to defend us along the coast, is doing what it always does, which is spend a lot of money on pouring concrete, which in the end, a lot of that could be done cheaper. And in fact, pouring concrete is often just the wrong solution to the problem. We can't all live like New Orleans does. We can't afford to do that, build a big wall everywhere. And then there's FEMA. FEMA has two sets of jobs. FEMA has a job of emergency management. They do that fairly well. In preparation, after disaster is struck, they get people out of there. They take care of them. It's better than it is in a lot of places. But preparing for the next one, that's not their job, or hasn't been. And that has to change because they are a repository of a lot of the power and money that has to get fed into the system to let real adaptation happen. And then the relationship between the state government, the federal government, where most of the revenue is raised, and the state governments and the local governments is set up to fail on adaptation. Federal government has the money, the responsibilities for most of what goes on are at the state and local level, and the money doesn't get down. And that has to change. The Biden administration has made some moves in the right direction, but I don't know if the next administration is going to feel the same way. And even if they do, these are big bureaucracies. They're huge institutions. And even they are very difficult to change.
Even at the level of human psychology, I often think that we are adapting primarily by normalizing impacts. So you mentioned really just quickly as an aside a few minutes ago that 60,000 Europeans died in the summer of 2022 because of heat. This is a scale of death from heat that shocked Europe in 2003 when it happened. It shocked Europe in 2010. In 2022, it barely made the news. I mean, that's a slight overstatement, but it was not nearly the shock that happened in 2003. We just kind of got used to it. And that's, for me, what I really worry about in these questions.
Well, you're right. Do you want to get used to that?
Yeah, of course
Do you want to live in a world like that? No. So we need to set up the mechanisms so that we don't get inured to the whole thing. And if we get inured to it, we're turning over to our kids and grandkids a miserable world.
So, Stefan, before we go, one last question for you is, if you more centrally focus on tipping points as a risk, how does that change how we think about adaptation and response? Like, what should we be doing differently if we were more worried about, the shutdown of the AMOC, but secondarily, or, the consequences to the Amazon and the ice sheets? What would an adaptation response focused on those risks look like to you?
Well, I think that really shifts the balance more towards the mitigation, because it is very difficult to have an adaptation strategy if you think it's getting warmer, but you don't know from a certain point it might be rapidly getting colder in Great Britain or Norway or so. How do you adapt to that? So that is it makes adaptation very tough. And I mean, we've already crossed at least one tipping point, namely for the coral reefs, and 500 million people rely on coral reefs for food, for income, for coastal protection. They already have to adapt, whether they want it or not. And crossing these tipping points just makes adaptation so much harder. And that's why, we have to manage the unavoidable, but avoid unmanageable climate change. And crossing tipping points is kind of getting into the unmanageable climate change regime.
So on that optimistic note, thank you, Michael and Stefan, for coming.
Yeah, thanks.
Thank you.